Hello students, I am Dr. Sanjeev Punia. In computer graphics, last lecture we discussed about three-dimensional viewing. We discussed that how we can represent a real object, that is 3D object in 2D object or 2D image. There we discuss about the projection also, that what are the basic type of projections. Let us summarize once more because this is the very important, and from projection there is always one question. Either they ask the difference between parallel and perspective projection, or the difference between orthographic and oblique projection. And this is a completely theoretical unit. So we have to pay more attention and try to understand. In last lecture, we discussed about parallel projection, and we see that how the parallel projection and perspective projections are different with each other. Here we will study about the perspective projection in detail and their classification. So as we discussed in last class, that basically projections are of two types. First one is perspective projection, second one is parallel projection. We can divide perspective projection in three parts. First one is 1 point projection, second is 2 point projection, and third one is 3 point projection. We know that in perspective projection COP, that the point from where light source is, or from where the projectors came on the object. So this was about the perspective projection. Today we will discuss about the parallel projection. So in parallel projection is also basically two types. Broadly it can be divided in two classes. First one is orthographic and second one is oblique projection. Again, we can divide oblique projections also two parts, whereas orthographic projections also in four parts. So first we will see the types of orthographic projection. So these are different type of orthographic projection, as the rays are parallel in this case. So it can be a top projection or top orthographic projection. It can be a front view, it can be a side view, or it can be axonometric, where axonometric can also be divided in three parts. First one is isometric, second diametric, and third is trimetric. Whereas oblique projection can also be divided in two parts. First one is cavalier projection and second one is cabinet projection. So this was the broadly projection scheme that we discussed in last lecture. This is all about the projections, different type of projections, and we completed from projections to perspective projections and its different type. So today we will start from the parallel projection. We discussed this in the last class that how the perspective projection is different from the parallel projections, and we saw one example of this also. And we have to study generally the perspective projection, as in this we get the realistic look of the object as in our day-to-day life. We discuss in detail the difference between perspective and parallel projections also, based on their different characteristics. Now we, now we discuss all the different type of perspective projections with their example. So today we will go in depth with parallel projection. So parallel projection, once again, I am trying to show you that how it is different from the perspective projections and complete detail of the parallel projection. Because when you will came to know the difference, the reality between these two, then it will be easy for you to write the differences between these. So parallel projections are also basically two types. First one is orthographic and second is oblique. We discuss this also, but when we discuss about the projects, this one, so that was complete about the projection. Here I am telling the classification of parallel projection separately. Means from the last slide, if you will see that over here we discuss about all the projections, but in parallel projections we will start from here and we will see it again one by one. So presently we are starting from parallel projection. As I told show you the slides, there we divide the parallel projections in two parts, that is orthographic and oblique. You can see from here that we divided the parallel projection in two parts, that is orthographic and oblique. Then oblique projection is divided in four main different categories, where top orthographic parallel projection, front, side, and axonometric orthographic parallel projection. And orthonometric orthographic parallel projection can also be divided in three parts or three categories, that is isometric, diametric, and trimetric. Whereas oblique projection can also be divided broadly in two categories. First one is cavalier oblique parallel projection, and second one is cabinet oblique parallel projection. So first we will try to understand the difference between orthographic and oblique projection with their difference. So parallel projections is of basically two types, orthographic and oblique. We will see the difference that in orthographic, the rays are parallel to, suppose this is our view screen, this is our view screen, and all the rays, we I told you that all the rays are parallel to each other in parallel projection. So when all the rays are perpendicular to view plane, means all the rays make an angle 90 degree with the view plane. In that case, that is called a orthographic projection, means where angle between plane and rays are 90 degree. So, and in this case, in orthographic, the rays are again parallel. The rays are again parallel. These are the rays. But it does not make a angle 90 degree with the view plane. So this is not a 90 degree angle. You can see that all the rays are parallel over here. All the rays are also parallel over here. It means it's an example of parallel projection. So in orthographic, this is the projections rays are perpendicular, as I told you. In this, they are not perpendicular to the view plane. For an example, as I told you, when rays will come, these are the projectors or the projective rays, or the rays, those forms the image of an object, and this is the image plane. Then these are perpendicular, and in this case you can see that these are not perpendicular. So this was the basic difference between orthographic and oblique projection, and generally it is asked in the exams. We can divide these in different parts also. We can classify orthographic and oblique in subparts also. First, we will try to understand the difference between these two in detail, as this question is really most important for the exam purpose. As we discuss the difference between parallel and perspective projection using their characteristics, so we will see over here also. Based on the description, based on their description, orthographic projection can also be described as two-dimensional graphic representation of an object, in which the project lines are right angles at the plane of the projection. As I told you that these rays are at the perpendicular, at the right angle, and these are not orthogonal. In oblique, the rays are not orthogonal. Forms, it is a form of parallel projection. This is also the form of parallel projection, as I told you that these both comes under parallel projection. Types we will study after this, the types of orthographic and oblique projection in detail, but you can see over here that the types of orthographic are isometric, diametric, and trimetric, whereas the type of oblique projections are cavalier projection and cabinet projection. So these are different types. When we want to differentiate based on the projector lines, then the projector line intersects the plane being projected on to at a perpendicular angle. in oblique, not a perpendicular angle means not right angle. Angles value can be different. Orthographic projections are used by engineers, designers, architects, and technical artists, and oblique projections are generally used in technical drawings. So these are basic applications of these orthographic projection and oblique projection. So this was the basic difference between these two. Now, orthographic projection can be divided into four basic categories as we discuss. This is top orthographic parallel projection, front orthographic parallel projection, side orthographic parallel projection, and axonometric orthographic parallel projection. We will see the top, front, side, and all these that what happens with the example. This is the object. Now I want to take the front view, side view, and top view. As I told you that all the rays are parallel, so rays will come from this side. Let me draw. When I want to see the top projection, so all the rays will come from top to bottom, and these will be parallel to each other, and we will see that how this object look like when this is when the rays are perpendicular to its base, and when this object has to be seen from the side, means we have to see the side view of this object, then all the rays will be parallel, and we will see that how the image of this object will look like when COP is over here. Same in the case of front view also, that how the image of this object will be. So we will see the top view, side view, and front view as we discussed in the last slide. You can see once more from here that this is in orthographic. We have to discuss about top, front, and side. As axonometric can again be divided into different types. So first we will try to understand the difference between these three. So this is a object. We want to see the top view, the front view, and side elevation. As from here you can see top, front, and side. So over here this is the object, and we will try to find out the top view, front elevation, and side elevation. So this is the top view. You can see from here, when a person want to see this object from this position and the rays are coming from the parallel, then I told you that the size of the image is equals to size of the object. So whatever is the length of this object, whatever is the length of this object, that length will be equals to this. As you can see that this ray is coming from this point, this ray is coming from this point, and these are parallel to each other. So this distance and this distance both are same. When we want to see from the front, then from this corner this is the parallel ray, from this corner this is the parallel rays, and this distance is same as this distance. When about this one, when we will see this from the top, then it will not look like 3D. We will see that this is a flat surface, but as this is the line, so this line will come in between. As you can see over here in this image, it will look like that there is a line between this. So the distance of this width is same, distance of this is same, distance of back, that is this one is same, this is same, this is same, and this is also same as the object. So this was about the top view of this object. When we want to see about the front view or front elevation, then this is the front elevation. You can see from here that when a person want to see this object from the front, then this distance will be equals to this distance. When the projected rays are coming from the infinite, and as I told you that we can see only two dimension, that is either x and y. So here we are seeing the x coordinate and y coordinate. So this is the reason that we cannot see the depth of this. So only the image have this part, and these all, that is this one is equals to this length is equals to this length, and this length is equals to this length. Means all the lengths etc will also be same. So this was about the front elevation of this object. In the case of side elevation, in side elevation, the third direction, depth that is depth will not be able to see. We can see only this direction and this direction. So from here we can see this edge is equals to this edge, the other edge is equals to this edge. As when the rays are coming parallel, this edge is equals to this edge, and this edge is equals to this edge. Now you can say that how this part came from. So this is the top of this object. This is the top, that is roof of this object. So when you will see the roof of this object from the side, then it will not look like this, it will look like a vertical plane. It will look like vertically. So this is the roof view of this object. So this was all about the top view, side projection, and front projections. Once more, you can see over here that when we have to see the top view, front elevation, and side elevation of this object, that top view is like this, front elevation is this, and when we want to see this from the side, then side elevation of the object will be like this one. So when we will combine all these elevations, all these projections, then it will be like this. So this is for the top view, this is for the front elevation, and this is for the side elevation. So this was all about the top view, front elevation, and side elevation of the orthographic projection. Now, as fourth projection, that is axonometric projection, is left. So in axonometric projection, this is also of three type. First one is isometric, second one is diametric, and third one is trimetric. So over here, I will try to tell you by an example. So let us see an example of this. In isometric, all the angles are same. From here you can see that angles. This angle is 120. This is also 120, and this is also 120. Isometric means all the angles are same. Diametric means two angles are same. You can see from here that two angles are less than 120 degree, whereas the third angle is more than 120 degree. And in trimetric, all the angles are different. You can see from here that the value of A is different from value B, and the value of C is different from value B and A. So this is the basic difference between axonometric projections, that is isometric, diametric, and trimetric. Now oblique projections is also of two types, and this is also one most important projections, for which sometimes they ask in the exam between these, and they ask to write the difference between Cavalier as well as cabinet projection. So in Cavalier, the projected lines length are same, but in cabinet this is half of the length of the original object. Means when we have to find out the image of an object in Cavalier, in that case we have to take the original length of the object, or we want to see the original image of the object. But in case of cabinet, we take the half the size or half the length of the object, and after that we see that how it look like in a 2D plane, or how it is going to represent in case of cabinet projection. So basic difference between these two is to check the image on original length, as well as dividing the length by 2. So we can see this by an example. In Cavalier projection, whatever is this length, we are getting the image of this object with the same length as it is. Suppose this is A, then we are taking the A. Suppose this is also A, then we are taking A. But in this case, you can see over here that we are taking 1 by 2 of A. This is A and this is 1 by 2 of A, that is half of A. So this is the difference. I told you that projected lines are of same length, and in this we have to project the lines on half of the length of the object. So from here it will be clear to you. So this is about the cabinet projection and this is about the cavalier projection. In these two, cabinet projections looks like more realistic than cavalier projections. So this was about the projections. Now there is one more thing in this unit, but that is not in our syllabus. Only for your reference, I am telling you that what is that. I am only giving you the idea of view volume. What happens in the view volume, as this is our object, this is our object, we have to make two images of the object. We are taking the example of perspective projection. So in this case, this is the COP, that at a definite distance from the object. So first image of this will be over here. So this is the first image. This is the second image of this. This that is also called far end clipping. So this is first one, this is second one, then space between these two is the complete space between these two is called the volume. Whatever the area between these two, we can find based on the area the volume of this space. So this is called the view volume. Suppose I want to change the location of this image, or I want to see this image, then in that case the volume of the perspective projection will change. So this is the value between the far clipping plane or far image as well as the near plane. This same can be in the parallel projection also. So you can see over here that in the parallel projection also, this is the object, this is the object, and this is the image of this one, that is near image or near plane object, and this is the far one. Then the distance between these two is this. This is the distance between far plane and near plane. So based on this distance, this height and this depth, we can find out the volume in case of this parallel projection also. But this is not in our course. So this was only for the reference that how we can find out the view volume in case of perspective projection and parallel projection by defining the far plane image as well as near plane image. So volume depends on the window size it depends on the window size and the distance between these two images. So volume depends on the size of the image. Suppose the image will be of this size, then the volume will be more, and the distance between these two. Whereas shape depends on the projection type. As in parallel projection, shape is same as an object, whereas in perspective projection, shape is going to be changed based on the distance of projection reference. But one more thing in this, that we have to keep in mind that both the planes should be on the same side of the reference point. This is the main important point to remember about view volume. So this was complete in details of the projections, that how we can divide the projections and what is the projections. In this we discuss the projections in detail, that is we discuss about parallel projection. We discussed before this also, we discussed from the projection, that is, yes, let me come over here, yes. So we classify the projections in perspective projection, parallel projection, in 1 point projection, 2 point projection, 3 point projection, in parallel orthographic projection and oblique projection, whereas orthographic projection can be divided into 4 parts and axonometric projection can be divided in 3 parts, whereas oblique projection can be divided in 2 parts. Now let me summarize what we study and what is the difference between these two. So projection is a process that is used to convert a 3D object, that is real object, on 2D plane, that is on two-dimensional, and it is applied on the pixel by pixels. This is of two types, perspective and parallel. In parallel, all the lines are parallel to object, whereas in perspective projection, all the lines are coming from a finite distance from the object, means lines are not parallel. In 1 point we have to see the object from a 1 point only. In 2 point we have to see the object from 2 points, and then we have to combine the image. In case of 3 point, the image of the object from the 3 points, that is x, y and z, has to be combined. In parallel projection, when all the rays are perpendicular, that is at 90 degree with the image plane, then in that case that is orthographic. When they are not perpendicular to the view plane, then this is oblique projection. In orthographic projection, we saw the top, front, side and axonometric projection. In top, as we can see the top of a house or top of an object, and that will look like only in two plane, that is x and y, not in z direction. So we saw the example of these three also in isometric, diametric, and trimetric. In isometric, all the angles are same. In diametric, two angles are same, and in trimetric, all the angles are different. Whereas in Cavalier and cabinet, the ways of the projections are always different to each other, and the image that can be, you can see from here that in this the image is going to be formed by the half length of the object in case of cabinet, and in case of cavalier we have to take the original length of the object. In last we discussed about the view volume. As I told you that this is not the part of our syllabus, so in the, I think this is the complete description about the projection. You have to keep in the mind that they always ask about the differentiation between projections, in which differentiation between parallel and perspective projections, whereas orthographic and oblique projections is more important. So keep those projections in detail in your mind, so that, and try to understand, not to gossip the things, because when you will try to understand the basic concept behind the projection, then it will be really very easy for you, as these are the things, those are happening in real world and we are implementing in our day-to-day life. This is the reason that this subject is really very, very easy to understand, and the use of this subject is related with our daily life, and the things those are concerned with our daily life, those are easy to understand. So this is really very good subject, and there are no problem to understand the things if you will pay little bit attention only. So in next class, we will discuss about the three-dimensional clipping. Thank you. Thanks a lot. If you have any problem, then we will discuss in next class. Thank you.